All right, I'm going to start off by doing something completely different than what's on your piece of paper, so put your pencils down, look up here, and pay attention. Okay? I'm going to ask you instead, I'm going to start you off with the idea of what if I gave you, asked you what the derivative of 1/3 x squared plus 1 to the third is. What's the derivative of this?
It'd be 2.
What would I do, Laurel?
2x plus 1/3.
I would throw the 3 out in front, you're saying? So I'd throw the 3 out in front. The inside would become x squared plus 1 to the second power. Then what would I do? Derivative of the 2 inside, yes. And I get 2x. And so I'd end up with x squared plus 1 squared times 2x. Agreed. All right. So now I want to integrate this. Now pretend for a moment you can't see this. Let's say I want to integrate x squared plus 1 squared 2x times 2x dx. Let's write it better. This is one of these awful things where people are staring at the 2 and they can't figure it out. And that's not going to help me. What if I give you this? How do I go about this?
You leave it there.
Thus far, what do you know how to do with integrals? Power rule, because you can have to take derivative of power rule easily backwards. And then the second thing we know how to do is we know how to do sine and cosine, because those are one-step identities, right? We probably know how to do secant squared, because that's tangent. I got nothing else. This is the chain rule, right? To get from here to here. So I'm actually doing a chain rule backwards. Now the chain rule backwards is harder to do than the chain rule. The steps are going to sound familiar. And we have a whole little structure by which we do these. Okay? Because if you try to do too many things in your head, it'll melt in the middle and nothing will happen. And you just be paralyzed by, I don't know what to do next. Okay? Do you remember what the first step of the chain rule was way, way back when we looked at these things and said, I don't know. What was the first step?
U.
Stands for? Still does. So here's what I want you to do. I want you to find the ugly part of my integral. The part that is most annoying me at this moment. And I want you to set it equal to u.
X squared plus 1.
X squared plus 1. Let's do that. So I get u equals x squared plus 1. Now, normally at this point, we then take the derivative of that and tack it on to the end. We're going the other way. We got to get rid of the derivative. Instead of tacking on to the end, I need to suck it up and make it disappear. Right? Agreed? So now I take all this and go, all right, I got to find what the derivative of this is. So the first step is to make a derivative of this. So I'm going to go du dx equals, what's the derivative of x squared plus 1? 2x. So I need to delete a 2x. Is there any chances of 2x in my expression? Well, it's right there. Woo! Nice, easy problem for the beginners. Right? Sitting right there. So now here's what I'm going to do. And this is a weird step, but it's going to make your life better as you start to get used to it. Okay? And that is, I'm going to move the dx over to here. Like I'm multiplying both sides by dx. So I'm going to go du is equal to 2x dx. Agreed? All right. Now, can I make a 2x dx in this expression? Certainly, I kind of already made it. Good so far? Okay. So now look at this and go, I'm now going to do u substitution. I'm going to draw an arrow over this way. I'm going to say the integral. This was u, right? So this becomes u squared. And 2x dx is du. Now, why do that step? I'm actually quietly deleting. I'm executing the part that we made if I did the chain rule forward, right? We're doing the chain rule backwards, so I need to make it disappear. So this is a step where I'm magically making it disappear. Now, when you've done about 20 of these problems, you forgot what you're doing, right? Because you're just going to go through this process. That's what we're doing. We do chain rule backwards. Chain rule creates a 2x. If I'm going backwards, I need to make the 2x just disappear, right? So far, so good? Do you know how to take the derivative of this? Yeah, raise the power by 1, divided by the power I get, and tack on a plus c. Now, we don't want it in u form when we get done. What is u equal to?
X squared plus
It would be x squared plus 1 to the third power plus c. Look at that. It actually gave us the right answer. All right. So what are the steps? The steps are u stands for what, Laurel?
ugly.
Ugly. Then you're going to take the derivative of ugly. Then you're going to slide the dx over there. You're going to replace u with what u is. You're going to replace whatever du is with, you're going to replace whatever this is with du. Integrate like you know how. Put the x's back in. Agreed?
Yeah.
This is the #1 process they're going to make you do on AP on that May 11th day. This is it right here. Let's practice. Try number got it.
I don't.
Actually, I should back up.
Wait, but it says take the integral.
Thank you. All right, so I've got the integral of 5x squared plus 1 to the second power 10x dx. I look at this and go, oh, this is fun. I'm going to say u is equal to 5x squared plus 1. Therefore, du dx is equal to 10x. Agreed? du equals 10x dx. It's like, oh, sitting right there. Life is good. Gee, these problems aren't bad at all. I don't know why Mr. Resny is talking about these things being a slightly scary proposition. 10x dx is just du. This becomes u to the third, 1/3 plus c. I get 1/3 of, put the u back in, 5x squared plus 1 to the third power plus c. Agreed? So life is good. Do the next one. I am warning you in advance, the next one is not going to turn out like Disneyland. You're going to have to work a little.
Come on, just put x through the little things.
You're going to super foil the whole thing?
For what? Like crazy.
That's why it's going to be 7th power by the time you see it on the test.
That would work.
It would. The chance of you not making an error is about 0.
What? Hey, I'm a professional.
Oh, I should be pausing. I shouldn't put that recording. I'll edit it later. No, I won't.
Like, you know how to edit.
I know how to edit. The thing is easy to edit. I just chop whatever I want to edit. Got a little gray spot. Tricky part is keeping stuff you want. It wants to delete the whole thing. All right. So I get started this problem. I look at it and go, ah, U stands for ugly. Chris, what's the ugly part?
X squared plus 1.
X squared plus 1. Love it. So then du dx is going to be equal to
Oh no, 2x.
2x, yeah. So du is equal to 2x dx. I'm feeling really good about what I've done so far. So I'm going to integrate. I'm going to reorganize this a little bit. I'm going to write this as x squared plus 1 squared x dx. Am I ready to go, Chris?
I thought we're plugging into u.
I'd love to plug into u, but I have to have it be 2x dx for me to replace it, right? Is there a 2x dx sitting here? That's a problem.
So this should be du over 2.
So here's what we're going to do. I need a 2 there. So I'm going to put 1 there. I'll put 1 there. Now, I violated every mathematical thing in the history of mankind, so now I have to figure out how I'm going to fix that problem. How I'm going to fix that problem is what times 2 is going to give me 1, make it go away? A half. So I'm going to multiply the outside by a half. Right?
This is stupid.
I'm going to make it do what I want it to do. Now am I ready to go, Chris?
Yeah.
Yes. So I'm going to go ahead and go down to the next step. I got 1/2. I'm going to integral u du, u squared du. Agreed?
Yeah.
Raise this power by 1. Divide by the power I get. Take a 1/2 out in front, plus c. So far, so good? Distribute the 1/2 through, I get 1/6. What's u?
X squared plus 1.
X squared plus 1 to the 3rd power plus, uh-oh. What's 1/2 of c?
1/2 C.
1/2 c, which I could write as 1/2 c if I wanted to.
Right.
Or, being a calculus student, I could do the following. This is going to drive some of you to complete distraction. We might as well start practicing it now. Wouldn't it just be c? Whoops.
I still like it. Wouldn't
Wouldn't it just be c? I mean, half a c, we don't even know what c is. Wouldn't it just be c?
I love it.
It's a number. We know it's a number. Half a c is half another number. It's a number. Still c. You want to put a c1 down here, make you feel better? Okay, fine. That's good. Whatever you want to do. As calculus students, we get really crazy with these c's. You're like, ah, c is equal to c plus c. Yeah. All right, for homework, I want you to try at least the first 2 on the back. First 2 on the back. We will pick